Today's problem is symmetric tree, difficulty easy. Let's see. Given the root of a binary tree, check whether it is symmetric, i.e. whether the tree is a mirror image of itself. A tree is symmetric if the left subtree is a mirror reflection of the right subtree. Example, this is a symmetric tree. The left subtree is a mirror image of the right subtree. Now, to be clear about this, let's look at the next example. What about this? This is not a symmetric tree, although the left subtree is identical to the right subtree. That's not what we want. We want a mirror image. So for a mirror image, this 3 can't be here. It would have to be the left the left node of the 2 here. Okay, but this one works. Again, the trees, the left tree and the right tree are not identical, but they are mirror images of each other. So that's what we want. All right, we can have up to 2,000 nodes. That's no problem. Expected complexity, O of n. Yeah, we'll look at each node. Company tags, Amazon and Microsoft. Okay. I've heard of them. Topic tags, tree data structures. I guess I could say recursion, although recursion isn't the only way to do it. But, you know, for tree problems, that probably should be the first thing that pops into your mind is, is there a recursive way to do this? And in this case, there is. So let's take a look. Here's what a node looks like. It looks like what you would expect it to look like. It has a data field containing an integer, and then it has pointers to the left node and the right node. Okay, constructor. You don't have to construct any nodes. Can I scroll this up? Oh, I can't. Okay, so here's the method that they give us is symmetric, and what we can do is, so we need a helper method for this. So we're going to compare the left and right trees, right subtrees recursively. We need a helper function. There are several base cases for the recursion, and we'll look at those. The helper, let's call it isMirror. Okay. So let's pass in. Actually, let's. Can I scoot this up so that the tree and the code are visible? And not really. Well, in that case, let's put a break here. And let's put a break here. All right, now we can see everything. All right. So what we would pass in is the left node and the right node. We're guaranteed with the constraints here that there's at least one node. Okay, so we don't have to do a check anywhere to see if root the root that's being passed into this is null, because we are assured that it isn't. All right, so we'll pass in the, no, I'm going to go back up here. We're going to pass in this case, both of the 2 nodes. All right, here's the base cases. If the left and right nodes are null, then return true, because that would be those would be mirror image. Now, if left is null or right is null, and we've already established that they're not both null, if one of them is null, then we got to return false. Or if the data is not equal, we got to return false. Those are the base cases. All right. If none of those, if none of the base cases applies, then we'll do then we're good so far. I mean, in this case, we would be good so far. We get the two, we get 2 and 2. They're not null. The data is equal. So now we're going to do a recursive call, comparing the left node of the left subtree and the right node of the right subtree, as well as the right node of the left subtree and the left node, wait, what did I just say? As well as the right node of the left subtree and the left node of the right subtree. So we've got, what do we have here? We have to have left, left, and right, right have to be mirror images. So what do we have here? Left, left is 3. Right, right is 3. So we're going to get a true on that. Left, right is 4, and right, left is also 4. So we're going to get a true on that. Okay, so yeah, so we can solve this recursively. Let's do this. Let's scoot this over here where we can see the results come in. I'm going to submit this. All right, 1 geek bit. I don't know what geek bits, what the exchange rate for geek bits are, but anyway, that was a pretty easy problem. It's a recursive tree problem. So anyway, like the video, subscribe to the channel. I try to post one of these every weekday, and if you're subscribed, you'll get a notification right in your inbox that the new challenge is up. You know what I should say at the beginning of these? I should say, try the problem yourself before just watching the video. I'm going to start doing that in the future. Definitely try the problem yourself. These are all on Geeks for Geeks. You can go out there and look them up. All right, so that's it, and see you next time.